We think we know what computers are for. But what if I told you they're not just for spreadsheets and social media? What if they're actually our keys to unlocking incredible hidden worlds? Today, we're going way beyond simple calculation to see how computers are making the invisible visible. I mean, we all use them every single day, right? There are go-to tools for work, for talking to people, for entertainment. But if you really had to boil it all down, what is a computer truly for? What's its fundamental purpose? That's the question we're going to dig into. The word computer itself is kind of funny, isn't it? It comes from compute, which literally just means to calculate. But today, that's like calling a smartphone a pocket calculator. It just doesn't capture the whole picture. The reality is, computers have evolved so far beyond that humble beginning. They're not just number crunchers anymore. There are portals to entire unseen realms.
All right, so if computers are our windows into the invisible, where do we even start? Well, let's start really, really small. I'm talking about a world so tiny it's almost impossible to imagine, the world of molecules. And we're about to see how computers are completely revolutionizing the ancient science of chemistry.
Okay, just look at this comparison. It tells the whole story, doesn't it? On one side, you have the old way of doing chemistry. Think years and years in a lab, endless trial and error, just hoping for a breakthrough. Now, look at the other side. That's the new way. You've got a scientist at a computer simulating millions of possibilities in just a few hours. It's the difference between writing a letter by hand and shooting off an email. The leap in speed and efficiency is just wow.
This whole new frontier is called computational chemistry. And honestly, the best way to understand it is to think of it like a flight simulator, but for molecules. Seriously, just like a pilot can test fly a new plane in a simulation before ever leaving the ground, a chemist can now design and test a new drug or a new material entirely inside a computer before ever touching a real test tube.
And this isn't science fiction. The applications are already changing our world. We're talking about designing new drugs to fight devastating diseases like cancer and Alzheimer's. We're creating new materials that are lighter, stronger, and better for the planet. We're even using this to tackle the deepest mysteries of quantum chemistry, problems that not too long ago were considered literally unsolvable. So we've looked at the incredibly small. Now let's zoom all the way out to the absolutely colossal. We're leaving the molecular world behind and stepping right into the heart of modern industry, where we'll find this this digital nervous system that's quietly running the entire show. At the core of this digital nervous system is a technology called a distributed control system, or DCS for short. The best way to picture it? Think of it as the conductor of a massive orchestra. Every single sensor, valve, and motor in a plant is like a musician, and the DCS, that's the conductor, making sure they all play in perfect harmony to create this amazing symphony of efficiency and safety. And this right here gives you a peek at that orchestra. If the DCS is the conductor, then all these wires, sensors, and controllers you see, those are the musicians. They're constantly sending information back to the conductor, who then makes tiny adjustments in real time to keep the whole performance running perfectly. And this is how that whole orchestra is structured. It's a hierarchy. You start at the bottom, level 0. Those are your individual musicians, the actual sensors and controllers on the plant floor. As you move up, you get the section leaders and supervisors. And then right at the very top, level 4, that's your conductor, the central computer that's in charge of the entire performance. It's this crystal clear chain of command that allows these huge industrial operations to run with such incredible precision. So where does this orchestra play? Well, in some of the most critical places on the planet. We're talking nuclear power plants, where a single wrong note could have catastrophic consequences. We're talking about the systems that deliver clean water to our homes and the refineries that produce the fuel for our cars. In these places, there is absolutely zero room for error, and that's why they rely on the unwavering precision of these digital conductors.
All right, so we've explored the world of the very small and the very large. For our final journey, we're going to turn our gaze inward, to a world that's somehow both infinitesimally small and infinitely complex, the world of our own DNA. This new frontier of discovery is called bioinformatics. You can think of it as the place where the language of life meets the language of computers. Biologists are the ones who are transcribing the book of life, our DNA, and bioinformaticians are the ones using computers to actually read that book and uncover its secrets. And this diagram just perfectly captures that teamwork. On one side, you have the biologists. They're the explorers, venturing into the wilds of our cells to bring back the raw data. On the other side, you have the computer scientists. They're the tool makers, forging the powerful instruments we need to make sense of that data.
And right in the middle, you have the bioinformaticians, the decoders who are using those tools to finally unlock the secrets hidden deep within our own DNA. Now, one of the key tools in the biologist's toolkit is a technique called chromatography. And the absolute easiest way to think about it is like a race. You take a mixture of different molecules and you put them all at the starting line. Then you let them race to the finish. And because they all have different properties, they all move at different speeds. By the end of the race, they're all separated, and you can see exactly what was in your original mixture. So let's break down that race. First, you have the starting line, where you apply your sample, then the starting gun goes off, that's a liquid or a gas that begins to push all the molecules forward. Now, here's where the magic happens. Some molecules are like little sprinters and they race ahead. Others are more like marathon runners and they lag behind. By the time they all reach the finish line, they're separated into neat little grips. And that's when the computer comes in, acting as the official timekeeper, identifying each and every molecule that crosses the finish line. And this molecular race is happening all around us, every single day. It's happening in forensics labs, where scientists are using it to identify tiny traces of evidence at a crime scene. It's happening in the food industry, making sure our food is free of harmful chemicals. It's happening in the pharmaceutical industry, to ensure the medicines we take are pure and safe. And yep, it's even happening in the world of sports, where it's used to catch athletes who are trying to cheat the system. So, we've journeyed from the heart of the atom to the heart of the factory, all the way to the heart of our own cells. And through it all, we've seen one common thread: the computer, not as a mere tool, but as a true partner in the quest for knowledge. This right here, this really gets to the heart of it all. The real magic of modern computing isn't just about crunching numbers faster or storing more data. It's about giving us new senses, new ways of seeing the world. It's about making the invisible visible. With the help of our computational partners, we can now see the intricate dance of atoms in a molecule. We can feel the pulse of a massive factory, and we can read the story of our own evolution, written in the language of our DNA. These are worlds that were once completely hidden from us, but now they are ours to explore, to understand, and even to shape. And so we're left with this tantalizing question. If this is what computers can do today, what will they be able to do tomorrow? As our computational partners grow ever more powerful, what new hidden worlds will they reveal to us? What secrets of the universe are just waiting to be discovered? The journey is just beginning. Thanks for joining me on this exploration.